Okay, let's do some examples for equation of plane. In this video, we have two examples, and in both cases, we need to write both form standard and point normal form. Well, first part is a plane which is through point -1, 2, 3, and is parallel to vectors u and v. Well, you should always remember I need a point. Here it is given -1, 2, 3, and I need a normal vector to be able to write an equation for a plane. Point is given, normal vector, well, is not. Instead of that, there are other information available. The plane is parallel to these two vectors, u and v. We are not interested in parallel points, parallel vectors. What we are interested in is a normal vector, a vector which is normal to the plane. I'm drawing vectors so that they seem that they are starting from a point on the plane, but that's just showing you what is going on. Well, it means what? It means that u and v being parallel, I have to use this information to create n. And if n is normal to the plane, it will be perpendicular to both u and v. And we are in R3, we have two vectors. Now we are interested in finding a vector which is perpendicular to both of them. And yes, you guessed it right. We can find that vector by finding the cross product of these two vectors. In other words, we are trying to find a cross product of 2, -1, 1, and 3, 1, -2. Well, 2, -1, 1, 3, 1, -2. And this gives us, okay, the first component is determinant of, ignore the first column, the remaining is -1, 1, 1, -2. The second one, we have to ignore the second column, and here then the remaining is 2, 1, 3, -2. For the third one, we ignore the third column. And that would be the determinant of 2, -1, 3, 1. Well, this determinant, multiply diagonal element, -1 to -2 is 2 minus 1. -4 times, -2 times 2, it is -4, minus 3 times 1 is -3, and the last one is 2 times 1 minus -1 times 3. And that gives us a normal vector. 1, -7 times minus sign, this is a 7, and then 5. Yes. Okay, now we found the normal vector. We know how to find point normal form. Normal form. It is n dot x minus p equals to 0. It means that we have 1, 7, 5 dot x is always x, y, z, minus p is -1, 2, and 3 is equal to 0. How about the standard form? To write the standard form, we always start with n dot x equals to n dot p, and we expand it basically 1, 7, 5 dot x, y, and z equals to 1, 7, 5 dot the point -1, 2, and 3. This gives us x plus 7y plus 5z. This dot product here, you see it is -1 plus 14 plus 15. This is 29 minus 1. This is 28. How about the second example? Okay, the second example has almost the same things. Point is given, 2, -1, 1. And there are two vectors which are perpendicular, which are parallel to the plane. So we can take their cross product as our normal vector. And this is, well, let's turn them to the component form. This is 1, j is 4, there's no k, 0, cross 1, 1, -1. Very nice. So this is a vector with 3 components. We have the 3 determinant of 2 by 2 matrices, which we will write it in this forms. Okay, here, well, to be able to have everything written down, I will write this here. Ignore the first column. Then that will give us 4, 0, 1, -1. Ignore the second column. You get 1, 0, 1, -1. And ignore the third column. We get 1, 1, 4, 1, 1. Well, find the determinants. Determinant is determinant of 2 by 2 matrix is diagonal entries here is -4 minus 0. Over there is -1 minus 0. Over there is 1 minus 4. And that gives us a normal vector. And now we have normal vector, a point. We can find normal form. Which is n dot x minus p equals to 0. That means -4, 1, and -3 dot x, y, and z minus p is 2, -1, 1, and that is equal to 0. How about standard form? Well, we always get standard form by expanding or performing dot product in this equation. So you have -4, 1, and -3 dot x is always x, y, z equals to -4, 1, and -3 dot p is 2, -1, 1. While the left hand side gives us -4x plus y minus 3z equals, right hand side gives us -8 minus 1 minus 3, and that adds up to -12 minus 4x plus y minus 3z. That is the equation in the standard form. This is the equation in the normal form.